Assalamualaikum warahmatullahi wabarakatuh, and a very good afternoon to everyone, especially to all of my panels. My name is Nurul Hamizah binti Komarudin. Today I am going to present my final year project entitled Muscle Activity and Gait Analysis of Assistive Device for Gait Abnormalities Patient. Okay. So, as for the introduction, I would like to introduce what is gait abnormalities. Gait abnormalities is when a person is unable to walk in the usual way with the cause of genetic problems such as stroke, injuries, underlying condition, or problems with the legs and the feet. Gait abnormalities impact includes hemiparesis with weakness partially on one side of the body and muscle weakness. So this is the device that I would like to analyze. So basically, the device is being fabricated to help the gait abnormality patient to walk easier. The mechanism of this device is basically by distributing the body load from the legs to be shared with the hand in order to reduce the muscle stress and the contraction produced by the legs. So, next is problem statement. Issei et al. In 2017 said that the degree of recovery of each affected leg can be determined by performing evaluation of abnormal gait. Thus, William et al. In 2018 said that further insight potential mechanism can be gained by examining the time course of fatigue after stroke. Thus, from the problem statement, I came up with the objective, which is to investigate muscle activity and gait analysis of normal and GA patient. Second objective is to evaluate the effect of the assistive device to the patient's muscle using surface electromyography, SEMG, and the third objective is to evaluate the effectiveness of using guard to improvement and time to fatigue to the muscle for the patient. As for the literature review, as we know, literature review is the past studies that have related with my current study. So here are a few of the studies. Okay, for the first one is from Nakai et al. 2019. The title is about trunk muscle activity during trunk stabilizing exercise. The summary from this research is about the muscle activity that was normalized to maximum voluntary contraction and muscle thickness normalized to resting muscle thickness. This experiment tests using EMG, electromyography, which is same with the device that I am going to use. Okay, the gap for the study is it may be used for the prevention and treatment of low back pain. Meanwhile, my study is about the leg muscle problem. Okay. So for the second one is about the electromyography activity of the quadricep and gluteus medius muscle during different straight leg raise and squat exercise. So for my study, I am going to use different activity, which is climbing stairs and walking. And the gap for this research is lack of measurement of pain levels in individuals in the PPS group during the various activities performed. Okay, PPS is pelvic-femoral pain syndrome. Okay, so and the last one is about the leg muscle, is about the electromyography activity of triceps, serrae, and tibialis anterior muscles. So the gap for the study is the leg muscles may be altered under ankle chronic instability conditions. Okay, so the scope for my study is it is basically located at the Melaka. First place is the Perkeso Rehabilitation Center at Melaka, and the second one at the Sekolah Menengah Bukit Maru, which is also Melaka. The scope consists of conducting the interview to the patient at Perkeso and Sekolah Menengah Bukit Baru, perform muscle testing using EMG, and analyze all the results obtained from the survey, interview, and surface electromyography. Okay, next chapter is methodology. So methodology, I start with the leg screening, whether to differentiate between the normal leg and leg with gait abnormalities. That is how I want to examine the muscle to study the muscle behavior of them. Second is EMG testing. The EMG testing is being run to this group of people, which is normal leg and the leg with the gait abnormalities. The next is data acquisition, which is two conditions, two activities, walking and climbing stairs. And the last step will be on analyzing the result. Okay, for the experimental plan, okay, from the previous is EMG testing. So for the EMG testing, I need to plan for the experimental. Okay, as you can see here, the first is I need to attach the EMG sensors to the muscle of the Gait patient and normal people, and then run the experiment with and without assistive device. Run the experiment based on the state activities, which is walking and climbing. The experiment is being repeated 3 times to collect the data and for me to evaluate the average. And the next is the experiment is conducted within the selected time frame, which is 10 seconds. So the patient and the normal people required to walk for 10 seconds, and I've been recorded the muscle activity of them. And the last one is obtain and analyze the results. Okay, so like the previous slide, I've been mentioning that the sensor is being attached to the muscle. So here are which muscle that I've been attached to the sensor, which is there are four major muscle. Okay, so the first muscle is rectus femoris, second is tibialis anterior, TA, the third one is peroneus longus, and the last one is gastrocnemius lateral head. Okay, the reason why I chose for this muscle is because when we do activities such as walking and climbing, these 4 muscles is the most utilized muscle in our body. Before start using the EMG software, I need to specify my subject, which is I need to fill in the form produced by the EMG. So this is the patient which the gait abnormalities. So I need to fill in the specification first before continue with the experiment. Next is skin prep. Skin prep is I need to ensure the skin before I attach the sensors is clean. So the first is wipe the surface of the skin and sensor with the alcohol pad. The second, allow the skin and the sensor to air dry for a few seconds. The third is I need to ensure there is no excessive hair from skin at the detection site, as it can prevent from the sensor directly contact to the skin. And the next is apply the sensor to the skin using Delsys adhesive sensor interface. So the interface is the name of the sensor that have been used for my EMG collection data. Okay, next is identification of muscle. Okay, after I identify muscle, which muscle I am going to use, so I need to identify on the EMG software itself. So I need to select which muscle that I am going to use with selected sensors. Next is the relationship between objective and methodology. As we can see, I need to ensure I can achieve the objective through my methodology. Okay, so first, to investigate muscle activity and gait abnormality of GA people, I am using the electromyography. The second is to evaluate the effect of the assistive device. So to achieve the objective, I am using electromyography and utilizing the assistive device to the patient. And for the third objective, which is to evaluate the effectiveness, I am using the objective is through analyzing the result and data produced by the EMG and Microsoft Excel, which is I am going to calculate the percentage between the patient with the device and without the device. This pilot study, this is study that have been conducted prior it is not too detailed. So this is the result from the pilot study. Then let's get to the most crucial part, which is the result and analysis. Based on this graph, this is the average RMS, which is root mean square value of 4 different muscles for normal people. So the reason data is to compare between the normal person. As we can see here, pink color is representing for first sample 1. For the brown color representing for the second sample, and the dark blue color is representing the third sample. As we can see here, S1 and S2 has almost similar pattern, but not for S3. There is contraction. S3 has higher contraction compared to S1 and S2. But before forget, let me tell you how EMG works. Okay, basically EMG is a tools. EMG is electromyography. It measures muscle response or electrical activity in response to a nerve stimulation of the muscles. The EMG will detect the So basically EMG detects abnormal muscle through the electrical side. EMG detect the muscle through the electrical signal that be sent to the sensor and translated by the EMG software. Okay, so proceed with the graph. So S3 has a higher contraction of muscle. There is a few possibility why is this happen. First is the muscle of sample tree is really in a stress condition. That is why the sensor, the EMG, detect a higher contraction, higher signal of muscle. And the second one, the presence of external noise that may affect the electrical signal. Okay, so as you can see here, there is 4 graphs which representing 4 types of muscle. The first is rectus femoris, second is tibialis anterior. The result is about the average root mean square of normal people, whereas gait abnormalities patient during walking. As you can see here, this data is a comparison. First of all, the red bar representing the average of normal people, and the second bar which is the brown representing the gait abnormality patient. So as you can see here, all of these 4 muscles show the same pattern, which is the gait abnormality patient have a higher contraction of muscle compared to normal person. This is the reason of why gait abnormalities patient tend to have a shorter value of time to fatigue. Amount of muscle contraction is inversely proportional to time to fatigue. The higher the muscle contract, the shorter the time taken to fatigue. With the next result. So basically this is our significant finding. Okay, this is the average data of average root mean square value of gait abnormalities patient with device and without the device. So as you can see here, the pink bar representing the patient with the device and the brown bar representing the gait abnormality patients without the device. So as you can see here, the patients without the device has a higher contraction, muscle contraction, compared to the patients with the device. For the first muscle, which is rectus femoris, the percentage reduced is about 66%. Okay, the percentage reduced. The second muscle, which is tibialis, and which is traction reduced by 73%. And for the third muscle, which is peroneus longus, is 77% reduced. And for the last muscle, which is GLH gastrocnemius lateral head, reduced by 86%. Oh, so this graph is representing the activities of the patient during walking, and for the second graph representing the patient during the climbing stairs. So as you can see here, is graph still showing the same pattern, which is the muscle contraction with the device are lower than without the device. For the first muscle, the contraction has been reduced by 61%, and for the second muscle, which is the tibialis anterior, the muscle contraction is being reduced by 69%, the third by 33%, and the last muscle, which is RMS, reduced by 84%. Without any hesitation, we proceed with the discussion and conclusion. The discussion observe that muscle activity through the results obtained from the SEMG. And the second is the effect of the device to the gait abnormality patient has been proven by the result, which shows that the muscle contraction has been reduced with the device. And the last is the effectiveness of the assistive device can be observed as it managed to reduce the contraction of patient muscles as well as increase the time to fatigue. As for the conclusions, objectives are achieved through the results and analysis obtained in the previous chapter, in the previous slide. So here I would like to share some recommendations in order to improving this. First is increase the size of sample in order to obtain the more accurate data of result. Actually, we are having some complication in getting the sample, as we know this current situation due to the pandemic COVID-19. The next recommendation is to investigate the condition where the noise resulting from surrounding as it should be reduced during EMG data acquisition. And the last is analyze EMG signal of muscle to fatigue for other conditions. This may not necessary during walking and climbing stairs only. Okay. So I think that's the end of my presentation. So we see at the question and answer session. That's all. Have a nice day everyone and stay safe.